morning, all. This is Ellen Maria Kaligeraki on behalf of Majori. I'd like to welcome you. I'd like to welcome you in the Valenciaport pilot event, which is the first pilot demonstration of the Cyrene project. In this pilot event, the aim is to demonstrate the Cyrene solution and to evaluate Cyrene platform and its components by the end users and give us a viable feedback under real conditions under the scope of a threat scenario. And this feedback will be considered as improvement to our Cyrene platform until we deliver the final version of Cyrene.
Before starting, only two things. First, welcome everyone. I'm Pablo Jimenez from Fundación Valenciaport, and also people present online. Welcome to this event. The meeting is going to be recorded, so we are going to use it then as dissemination material. We are going to have a Q&A session at the end, so you can ask all the questions you have or put it in the chat for people connected. And we will send you, as was played by Elma, a questionnaire in order to get feedback from you to improve our platform and component. So now, Elma, if you want to start.
I'd like to first of all thank the Port of Valencia for hosting this pilot event. So, as Pablo said, we will start with the Cyrene overview. We'll then continue with a detailed description of the Cyrene platform architecture and its technical modules. Then we have a short coffee break, and then the real pilot execution. First, the description of the scenario and the pilot execution, and then Q&A. So, Cyrene project is aims to certify security and resilience of supply chain services. It is a European Horizon 2020 research project under the Research Innovation Action funded program of the European Union. It has a consortium of 14 partners coming from 10 different European countries. It has started at 1st October of 2020 and will end this September, by the end of this September, and its duration is 36 months. So here you can see all the consortium members coming from academic and research areas, security and IT, and industry domains. So first, I would like to identify what is the supply chain. A supply chain is an ecosystem of very complex procedures, different organizations, the majority of people, technologies, assets, architectures, which create interdependent sets of resources and processes targeted at first by the sourcing of raw materials, ending up with the delivery of products and services to the end customer in terms of transportation means. So here we focus on the delivery of service, the supply chain service. So supply chains are enablers of global trade and economy. We have the supply chains coming from a majority of industry domains, such as healthcare, food, energy, software. Our case here in this pilot is the transportation, maritime transportation, and specifically the vehicle transport service. So, what if a sophisticated attack disrupts supply chain service? Would it have a dramatic impact to the normal operations of the supply chain? Would it have an impact on the European economy? Let us take two examples, two famous examples. The SolarWind attack of 2019-2020, where malevolent actors compromised the software Orion, which upon which utilized by 33,000 customers, and of them, 80,000 already were affected, and the loss was $9 million. We have also a European example of Belgium city, which occurred the late December, of Antwerp and Diet and Ginger cities that compromised municipalities. And for example, at this city, all Windows applications impacted of the municipality, and the adversary take advantage of 557 giga of data, and the ransom demanded. At the Diet city, services what were shut down, and also at the Ginger city, data was stolen from the police, which led to take advantage of information such as car numbers and plates, police vehicles, crime cases, personnel, sensitive information, and so on. So from this, we understand how important it is to secure supply chain services and to remain very resilient and to be more robust to such events. So supporting supply chain services consist of ICT devices which are interconnected into infrastructure, and these are network assets that spans multiple administrative domains. So what are the risks of ICT supply chain? The risks coming from the motivation of espionage, sabotage, foreign interference activities. So our aim is to protect the supply chain services in terms of maintaining security, protection of privacy, supporting resilience, maintaining accountability, and enforcement. This is the aim of the Cyrene project, to provide, to guarantee security supply chain services. In Cyrene project, the supply chain service is the target of evaluation according to the common criteria. What is target of evaluation? It's all the content that will be under security evaluation. So Cyrene considers three abstraction layers, three viewpoints, which is the business processes, the infrastructures, and the assets. So these are translated to the Cyrene methodology into three different evaluation views: the business, the holistic technical, and the sector specific. Within this pilot, we are going to illustrate the holistic technical evaluation view that we'll see later on. So a supply chain service consists of a number of processes, and a number of processes incorporate assets which operate for the execution of these processes. And these processes are handled by business partners. So in a supply chain service and the Cyrene methodology, we have two roles: the business partners, which are organizations participate for the performance of supply chain services, and we have the supply chain service providers, who we assume that is the representative of the entire supply chain service, and is the one who conducts the risk and conformity assessment according to the Cyrene methodology that you will see later on. And in our case, the vessel transport service, the Port of Valencia is considered the supply chain service provider with the representative. So we have, as we said, the business process consists of assets. Assets are maybe ICT assets, SCADA, IoT devices, and so on. So what are the Cyrene project offering? We have a structured risk and conformity assessment process, and tools for certification of supply chain services based on international standards and European legislation. We have also a certification assessment process of a dual use. This dual use is seen from two perspectives: from the supply chain service business partners, which they conduct risk assessment of their supply chain service assets in order to investigate their security and prepare a protection profile in order to further be subject to certification at a later stage. What is the protection profile? This term is taken from the ISO 15408, which is the common criteria, and a protection profile is considered a statement or implementation that justifies that the security requirements identified for the target of evaluation, which is the supply chain service, are met. So the second use of the methodology, of the Cyrene methodology, is to receive audits from to assessors to investigate if they meet the requirements for certification. So these assessors may be conformity assessment bodies authorized by the European Union, may be national certification bodies, or just auditors. So this project has proposed a cybersecurity certification scheme for supply chain services, which is based on the ENISA European Cybersecurity Certification Scheme. And it's enhanced to address specifically the supply chain service environment, but can be also adjusted to business organizations. So another Cyrene offering is the real platform of Cyrene and toolset supporting the risk and conformity assessment process that we see later on. So these are the specific steps of the methodology, the risk and conformity assessment methodology. And basically, we have step 0, which is to set the boundaries of the risk and conformity assessment process, where all business partners sign a security declaration and application statement, an SDA, in order to mutually agree that they're going to reach a specific level of security and implement controls, proper controls, and share sensitive information in order to conduct the risk and conformity assessment process. And then the other privacy considerations are signed with this agreement. So the next step will be the analysis of supply chain service. Here we identify all the processes that will be under examination. We identify the supply chain service assets participating in this process. And the aim is to build a supply chain service information security management system, an asset inventory that is going to be shown later on. The next step is the supply chain service threat analysis. In this step, we identify threats upon the under examination assets and process. And we continue with the vulnerability analysis, impact analysis, where we identify specific vulnerabilities on assets, and we further investigate their impact and make the further analysis. I must say here that the basic task for service follows a specific assurance level, substantial, as you're going to see the pilot. And this assurance level means the basis where we can see if this target of evaluation reaches specific certification requirements. So this substantial assurance level, according to the RCA methodology, is directly linked to the evaluation vulnerability analysis, with the vulnerability analysis of degree 3, which is the AVA1 according to the common criteria, where focused vulnerability analysis is required. And all these assurance levels are defined by the criticality of the exact supply chain service. And this supply chain service is a very production service, as we said. How we identify the criticality scale? We are based on the NIS2 directive, and we say we examine whether the service is executed by operators of important or essential services within the European economy. So the next step after the vulnerability analysis is to identify risks, it's the actual risk assessment. And we reach risk results and investigate what controls we have to undertake in order to improve the security. So then we have also to examine the compliance to security assurance certification scheme, and then make a cost-benefit analysis in order to review and provide the further actions for mitigating risk. So this methodology is based on the international standards, as I said previously. Basically, the conformity aspects are driven by the European Cybersecurity Act, by the ENISA candidate cybersecurity certification scheme, by the ISO 15408 and 18045, and namely the common criteria. And the information security aspects are driven by 27,000 ISO, and also the supply chain security aspects are driven by 28,000 ISO. We also consider for the vulnerability analysis the Common Vulnerability Scoring System, CVSS 3.1 of PERT, which is the scoring system to investigate the vulnerability severity on us. And we are also based for the criticality to investigate the criticality of the supply chain service of the NIS2 directive. So this is a UML diagram showing how all these standards are implemented in our methodology and in our platform. So the output of Cyrene is the risk and conformity assessment process and methodology, is to deliver the specification of the assessment schemes for supply chain services based on the needs, as I said, is the tools to support the methodology, and best practice arising from these Cyrene platform capabilities. So its applicability is either horizontal or sector specific. Here we have an horizontal approach. Sector-specific approach will be shown in our next Cyrene pilot. So certification assessment scheme of Cyrene comprises of two parts, as we already said, which may be self-assessment by business partners in order to see if they can generate a resilient protection profile, and can be third-party assessment from conformity assessment bodies and so on. So what are the Cyrene users, team users? As we said, can be third-party assessors, supply chain service providers, and end users such as manufacturers, retailers, and so on. So the Cyrene objective will be to deliver a trusted ICT supply chain, to deliver a conformity assessment process that reflects different types of conformity assessment, to develop a multi-level evidence-driven risk assessment approach for supply chain services, to have the opportunity to dynamically forecast, detect, and prevent cybersecurity risks in terms of experimenting in a simulation environment and creating attack paths, as we're going to see in the next, and to validate these security supply chain service through real-life scenarios. And of course, to develop a set of best practices and standards, enhancements to cybersecurity and privacy assessment processes for these infrastructures. So milestones already achieved. In month 12, we have identified the requirements for the supply chain services. We have proposed a focused certification schema for supply chain services. We have developed a risk and conformity assessment methodology, and we have came up with a minimum viable product to illustrate the methodology of Cyrene into an architecture. So in month 24, we have delivered a full toolset supporting the methodology, a full featured version. And now we are running for milestone, next milestone in month 29, which is, as we start now, the pilot execution. And we have also conducted open call project commencement. So these are the Cyrene social media links. And if you are interested, you can view further information within this link. Thank you very much. Are there any questions? Or from the more remote audience? Thank you. So we then continue the description of Cyrene architecture by Ubiquitous to serve the technical managers.
Okay, hello everyone. I'm Petros Petru. I work as the senior software architect at Ubitech. Ubitech is the technical engineer for the Cyrene project, and we are going to present the technical details of the Cyrene platform. Okay, this is the conceptual architecture of the Cyrene platform. First of all, we have a security layer that is built on top of a EPLO authorization of an application mechanism implemented by Red Hat. Then we have a dynamic vulnerability layer that auto detects assets and some vulnerabilities, and then we can manage these vulnerabilities based on NIST open data sources. We have a dark web crawler in order to collect content from the dark web sites related to cyber events like the data leaks or calls for massive attacks. Then we have the threat detection layer for the anomaly detection. Based on SNORT, we monitor the traffic from the assets of the organization. Then we have the attack simulation layer, which executes some exploitability simulation for the assets of the supply chain service. So based on the asset vulnerability pair, we simulate some possible attacks, and we try to calculate the risk of this path. And then we have the layer of the risk assessment. All of the components, some components tries to support the final step of the end user in order to create the security profile. Finally, we have the polyglot data management layer. Now we have MongoDB, MySQL, and Elasticsearch to support all the visualization, the risk assessment, the other subcomponents. Okay, in the context of Cyrene, we have implemented a high configurable, semantic aware, and multi-thread dark web crawler that retrieves content related to cyber incidents or data leaks via Tor browser. Our crawler is keyword-based. That means we have some predefined cyber, let's say, keywords, for example, DDoS, ransomware, etc. And also keywords that we collect from the organization. This helps us to find content in the dark web related to the, for example, the Port of Valencia. We have a view that provides text analytics reports based on the dark web execution, private execution. And finally, we have the free text search. When we retrieve an HTML document, we remove the HTML tags, and then via the Elasticsearch, we can query the text of the document.
Good morning. I'm Gregory Chrysos. I come from PSI, and we work on the hardware-based platforms. Our component as far as Cyrene is the IDS, intrusion detection system. This algorithm, this framework is implemented on a reconfigured hardware. So here, these platforms offer acceleration, algorithm acceleration, and offload completely servers, VPF servers from this workload. The goal of this module is to check in real time the network packets that move inside and outside to the from external to inside the VPF network, and send information the Cyrene platform. The module, the IDS module, is directly connect the internal VPF suite, and as I told you, count all the moving network packets, and based on some rules, send this information when there are alerts the Cyrene platform. Here, down here, you can see an example for the rules that the component test. There is an action, what is going on when this type of packet or this information is detected. And these next are the information that checks about what type of the packet is this one, the source and the destination address, and the corresponding port. As far as the demo today, the IDS will detect, we put some IP rules on specific IP rules. So when someone from outside VPF tries to connect to VPF infrastructure, the IDS component will understand this and will send this information to the interface, to the Cyrene interface.
Good morning. I'm Matthias Schering, cybersecurity research engineer at Fundación. I'm going to tell you a bit more about the DDoS, the dynamic vulnerability assessment and testing systems. So the DDoS aims to detect vulnerabilities in an ICT system of a supply chain partner. And it achieves this by two different methods. It has a passive network-based vulnerability detection approach, and it has an active host-based vulnerability detection approach. Below, you will see a figure of where the DDoS is placed in this in the pilot. We have a span port on a switch connected to the DDoS probe. We have a connection to devices for the active detection. We have a Cortex decision-making instance on our own cloud system, and we have a Kafka server on the Cyrene platform to provide the result. A user can specify the credentials for active detection host at the probe, and they can specify the Kafka configurations in our cloud system. This figure shows the passive vulnerability detection. This uses a network-based traffic, as I said. They first extract the network traffic from the switch. It then uses an asset inventorization to detect assets. These assets are then judged based on a rule-based extraction, whether there are any network services that might be vulnerable on there. Those vulnerabilities will be scored, and that will be sent to the dashboard. The active detection takes a host-based approach. This means that it connects directly to a host. These hosts will then provide the software versions that the active detection needs to extract CPEs. These CPEs will then be matched to common vulnerabilities using the NIST database. It will then be assigned a CVSS score based on their vulnerability vector, and that will then be sent to the dashboard as well.
So, hello from my side. I'm Manuel Santipiros, and I'm from SPS presenting Everest. Everest is a runtime monitoring assessment tool that is built in Java, and it has APIs that monitor specific rules that can be customized from organizations that we assess. This module is composed of two submodules, the database of the monitor and the monitor itself. And regarding the Everest, the rules that are being written are in event cartridge format and can check a variety of very abstract security rules. It is made integratable by rules, and this abstract environment help us assess the ecosystem of an organization, the cybersecurity ecosystem of an organization. We also have event captors that work directly with Everest. Event captors think about that like the aggregators of the primary information that we get from a system that we assess. So they work with the Elastic stack. We install some, let's say, log aggregators, namely bits that are described in the Elastic stack. And we aggregate information from system and assets, and they pass through normalization of the message, and then Everest through all the reasoning and produces some monitoring assessment results from the system. This information can also be aggregated through Logstars, which is an open server-side data processing pipeline. And we also have some customized event captors that we ourselves have made, and they produce this information alone. In BPF we installed Everest, and we saw an example of the availability of the service that we assessed, and you'll see from after how we information.
Okay. I'm Pedro again, and I'm going to describe the entities used by the collaborative risk assessment subcomponent test. As already described, we have the SDA workflow that initiates the supply chain service in the platform. We find some metadata like requirements, security objectives, and security requirements. Supply chain service provider also has to add the supply chain processes that will be used by the supply chain service, and also check the external business part of the supply chain service. Obviously, we need the asset inventory of the organization, and especially the supply chain provider, in order to then create the dependency graph, the relations between the assets. This acts as an input to the attack simulation, some components that earlier in the architecture. Also, end users have to set and define the process and asset criticality rules provided by the Cyrene methodology. These rules help us to autocomplete CVSS 3.1 environmental things of each vulnerability of each asset. CVSS 3.1, let's say, protocol supports three sub-metrics: the base score, the temporal score, and the environmental score. Take as seeds the base score from NIST data source, and then, based on methodology, we modify the environmental score that give us the real impact of this vulnerability for our supply chain service. Then, supply chain service provider with the external business partner have to define the cyber dependencies. This is actually the integration point between the supply chain provider and the external business partners, how their assets will exchange information actually. Then we have to calculate the cyber risk level of each asset. So with the execution actually of the risk assessment. This step is actually tries to measure the impact and present the impact analysis of the supply chain service. For our calculation, we use the attack potential, the vulnerability score, and the attack likelihood provided by Capet-Nitren. This is the threat attack likelihood. Last but not least, the attack behavioral simulation layer is responsible for setting potential attack path within the supply chain service infrastructure. As I mentioned earlier, we try to simulate attack based on the vulnerabilities. This component uses the attack complexity, attack vector, triple required in user interaction. Actually, the modified part of this field from the CVSS 3.1 subgroup of the vulnerability. Okay, this is the steps for end user to create and calculate the impact and the exploitability level of the supply chain service. As you can see, the first steps are related to the supply chain management. I mean, we have to define the processes, the assets, etc. Then we have an auto-generated step. Actually, if end users know the CP of his asset, can set the CP in the asset, and then we can connect this started with the CVs, common weaknesses, and attacks. We use CAPEX meter data source. From this endpoint, we can collect weaknesses and attacks, and then also there is the NIST open API that help us to retrieve CPEs, vulnerabilities, and their connection. Okay, when the end user finalize the supply chain management steps, then he can create a snapshot to MongoDB in order to create and execute the risk assessment. This is based on our attack scenario we will present later, and also the attack simulation that takes into consideration the asset vulnerabilities pair. So the risk assessment calculation are built on top of CVs, weaknesses, attacks, and attack potential. This is what we call scenario. On the other hand, attack simulation, takes into consideration only the asset vulnerability pair and the risk level provided by the risk assessment calculator. So thank you for your attention.
We are going to have a short break, and we are back here at 11 with the explanation of the scenario and the live demonstration. Hello again. Let's continue with the event. As I said, now we are going to see the scenario that we have defined for this demonstration in order that you are aware of what's happening during the live event. Okay. The pilot we have prepared is focused on the maritime transport processes. Specifically, we choose the vehicle transport service because we have a partner vehicle factory. In the scenario we have defined, the attacker is going to disrupt part of the port activity by interrupting some of the PCS services. Specifically, we choose an example, the port call request, which the port authority is the main service provider of this service, but it collaborates with other business partners, in this case, customs, terminal operators, and ship agents. In order to achieve that, we deploy this infrastructure in our premises. This is a test environment, so we have a demo PCS, not the real port community system, in one of our servers, the main server. We have other server where we installed some of the Cyrene components, in this case, Dibatch and Everest. And also from this server, we established a VPN connection to the Cyrene platform in the cloud in order to send the monitoring information and also the inputs. Finally, we have also the IDS physically deployed there. You can see the board in the image where it's deployed the IDS, and all is connected to the switch and with the connection to internet. And now let's review the pilot scenario script. What is going to happen in the lab? First, some credentials from a PCS technician are going to be published in the dark web, a website or a blog post, and attackers will get that credentials. Cyrene platform is going to detect that publication through the deep and dark web crawler, as we saw before. Then the attackers are going to use that credentials to access to the server, and the IDS is going to detect that access. After this incident, the security officer is going to analyze vulnerabilities in their infrastructure, in our infrastructure, to see if there are other vulnerabilities to be attacked. Then the attackers, once they are inside the server, they are going to stop this port service in order to disrupt the port call service. This service downtime is going to be detected by Everest. And finally, the security officer, after these two incidents, is going to perform a risk assessment, not only from our infrastructure, but the infrastructure of all the business partners that are in the supply chain. And for that, of course, they need a SDA, a security declaration agreement, with all these business partners. That will be the end of the demonstration. So now we are going to move to the real-time live demo. While Petros is accessing to the platform, I'm going to introduce each of the steps, and then my colleagues are going to explain what is happening in the network infrastructure, and also what are you able to see in the Cyrene platform. Okay, so first, a Port Authority report, confidential information and some credentials is going to be published in a blog post in the dark web, and Cyrene platform is going to detect that fully.
Okay, let's start. God of demos, stand by us. Okay. Yeah, this is the free text view of the deep and dark web, some component of Cyrene platform. Each time we retrieve a document from dark web, we have a classification module based on the keywords, and we set a category tag for each document. And now for the documents under the cyberattack category, we want to find if we have terms, if the document, contain terms related to Valencia. Okay, we found 3 documents. Let me highlight. Okay. Okay, we see that we have some usernames and passwords for Valenciaport as a sentence in the document. So then the next step.
Now the attacker is going to use these credentials to access to the server. So hopefully the is going to log in using SSH to the server using these credentials.
Okay, this is the interface for the IPS tool. The interface is split in 2 parts. The upper part describes the problematic network packets that are received, and this information is sent by the board to the Cyrene platform. Here you can see some test packets that we sent in the morning, and you can see the timestamp. Again, the information that about the information that is included in the packet that created the problem, source IP, destination IP, and the corresponding port. Also, IDS detects 3 types of network packets: ICMP, TCP, and UDP. So below this framework, we have 3 different graphical representations of the network packets that are received, as you can see here, and the packet that created the problem. So if we go here, now we want to run the demonstration. So if we go to the TCP data, here you can see the TCP reported network packet. We refresh, and as you can see here, our colleague George sent tried to log in and created a problem, an attack, and this attack is presented here that one specific packet with the problematic IP address was received, and this information is sent to the Cyrene platform.
Thank you very much. After this, the security officer is going to perform the vulnerability analysis using the bug. Colleague Matthias is going to explain.
Okay, so in order to mitigate an attack in the future or hack in the future, you can have a look at the dynamic vulnerability page, which helps you identify which assets are on your system. So above here, you can see that there are 2 assets that has detected this morning, and below we can see the vulnerabilities that are in these assets. So the passive vulnerability detection, as I mentioned this morning, shows 2 vulnerabilities. One here is an insecure network service as a web application. So you can see that it's an HTTP server that does not use any encryption on it, and therefore should be considered as potential vulnerability. And you can see over here in the description that there which IP address is hosting this server and which port it is hosting it on. We can also see that there's a net bias name service on this network that is also deemed to be insecure. On the right, you have an overview over the pie chart of the severity of these vulnerabilities. Both are ranked as medium, and below we can see the active vulnerability detection. So we have for active vulnerabilities, we have a CVE assigned to this with the common vulnerability enumeration, a base score of that vulnerability, the vulnerability vector that is assigned to that vulnerability, and a description that tells you slightly more about what it entails. Important is also to have links to a website that help you with patching this vulnerability, and of course, which asset this vulnerability is located in. Hopefully that will give you a good way to start on mitigating these vulnerabilities and preventing a hack in the future.
Now the attackers are connected to the server, so they are going to stop the service. My colleague Angel is going to stop it. And Everest is going to test the service downtime. So, Manuel, please.
Okay, so hello from my side. This tab is for the privacy and security. And you can already see the violations that come into the system. So I'll explain a little bit what we see here. So we have our asset that is being assessed, the event capture, and as you can see, we have testing the availability of this service. And at the start, we have the service available, and then the attack or DDoS, or we imitate the DDoS attack that brings down the service, and we can see that some violations starting to appear in terms of the availability security property. So this is view.
The service are being restored. Don't you refresh?
Yeah.
In a few seconds or minutes.
So we click the reset. And we can see some satisfactions popping up. Of course, we can see that the service is back online.
So now, after these 2 incidents, the security officer decided to perform a risk assessment analysis, and for that, they're going to use the Cyrene platform.
So as we said in the beginning, the supply chain service provider, which in this case is the Port of Valencia, first of all, conducts a security declaration application statement with all the business partners involved within this supply chain service. And the other examination process is the portfolio request, which engages the terminal operator, the ship agent, and the customer. So all of these partners conduct assign the SDA and identify security requirements, which after the risk assessment result, we investigate via protection profile if these requirements are met. And if these requirements are met, that means that we are subject to investigate to reach certification, so the security certification according to an adapted certification scheme.
Okay, due to time constraint, we have already created the supply chain service. As you can see, we have a view for the metadata of this SDA part already presented by Elma. We have the overall objective, the security objective, the requirements, the assurance level, and the other one that also from that fields we can infer the attack potential of the supply chain service.
The assurance level, again, we said that it's substantial and it's linked with the other one, degree 3, a focused vulnerability analysis is needed. And we also take care of the attack potential, and we consider an enhanced basic level of attack potential. What do we mean by attack potential? It's the effort of an attacker to launch an attack on supply chain service assets in terms of motivation, his resources, and his expertise. So we consider this level to reach security for this level, to tackle this attack.
Okay, basically transport service contains two processes. Let's check. We have port call request and logic start with process. As we already described, here we can modify the criticality of the process. This criticality is inherited by supply chain assets. So here, the asset criticality of the supply chain service is medium. Also, if we want, we can modify some fields, especially for the backup, in order to change the criticality of assets. In general, process and asset criticality rules are based on the backup plan or process or asset, and if an attack to this asset could affect the confidentiality, integrity, and availability of the supply chain service. So here is the assets for the selected process. Let's have a look and visualize this asset. This is the interdependence graph of the Valenciaport. Here is the PCS application. This asset is exposed to external business partners. So we have defined some side dependencies with ship agents and terminal operator. Then the prevention view. First of all, we have the asset vulnerability profile. What is this? We can, as already presented in the previous session, we can auto-generate pairs of assets and vulnerability if we have the CPE of an asset. Okay, for example, have the asset Ubuntu. The process is port call request. This asset has many vulnerabilities. Let's review this one. We have the base core metrics. We collect these values and the base code from the NIST data source, and then based on the Cyrene methodology, we auto-complete some fields, especially for the CI fields. If you remember, the criticality of an asset were medium, so CI requirements set to medium, attack vector is network, attack complexity is high. This is also inherited by the base score, and also the modified CIA fields.
So the environmental group is triggered either by the asset criticality rules or by specific adjustments in some methods conducted by the supply chain service provider according to the specific needs of the supply chain service environment.
Also, for the risk assessment calculation, we need the threats. I presented the schema earlier. So after the attack scenario, we can also auto-generate the triplets of asset vulnerability and threats. Here is an example. Okay, the supply chain service we have created has almost 1,500 attack scenarios. Then let's create a risk assessment report. Have to set a name. Now we create a snapshot in the MongoDB. It will take some time. Okay, perfect. Now we execute the risk assessment. And now we can have a report of the based on the attack scenarios for the assets of the supply chain service. For example, here we have 8 assets with risk level medium, 2 very high, and 2 with very low. Obviously, we present the highest risk level of each asset. So for each triplet, we calculate a score, but the overall risk level of an asset is the highest of the attack scenarios. There also, you can see some threats with very high attack likelihood that exist in our organization. And also, we have a heat map that presents actually the attack likelihood and the vulnerability impact for the supply chain service. Okay, now let's do a different assumption and change the process criticality. Okay, now the port call request criticality is critical. Let's review also the assets, the supply chain assets of this process. Okay, now the criticality is very high for all the assets. Okay, let's regenerate the asset vulnerability profiles in the attack scenarios. This will take some time because for each pair we update the environmental fields. If you remember, the environmental score was 6.5 for for example, for this asset. Now, the environmental score is 9.1. And also, you can see the data for the CII requirements and modified CIA fields. Regarding the attack scenarios, we don't have any difference because based on the asset vulnerability profile entity, we just join the threats. So we haven't any change here. Now let's create a new risk assessment report. Okay. Again, we create the snapshot in the MongoDB. So in general, we have a dynamic part and a more static part for the risk assessment reports in order to have a history of the risk analysis. And we execute the risk assessment. Okay. Obviously, now most of the assets, we have 10 assets with the risk level very high. Also, we have here more threats that the attack likelihood is very high due to the vulnerability impact. Actually, we modified the vulnerability impact through environmental score, and this creates this view. For example, you can have for this application a reporting. You can also provide a reporting per asset, per threat, and per vulnerability impact. So end users are able to have a full report of the infrastructure criticality.
After integrating with the protection device, this is part of the device.
Okay, now the last part of the demo, we want to execute a simulation environment. We have to select the supply chain service, the process again, the entry point of the attack. We will set this as application because this is the most critical asset, not only due to vulnerability, stress, etc., but also because it's the integration point with external business partners. And for target point, we are going to set MongoDB because it's a database system. Obviously, there VPF have already stored some data, so an attack would lead to data leaks, etc. Also here is the attack potential of the supply chain service. Okay, this is all the possible attack paths provided by the module. For each chain, we define an overall score, but also, for example, for this very high chain, we report the asset fields that give us this overall score. For example, the attack complexity to exploit vulnerability 2018 834 is low. The attack vector is network and exploitability is very high.
Then you will consider some methods for the CVSS 3.1, and you have enhanced this approach by calculating the vulnerability exploitability per asset. And here you can see the vulnerability for each asset node. But the overall, that you see before, was the risk of the attack path, the very high in control, illustrates the attack path risk.
I forgot to mention that all the tools are implemented in Java, and especially the simulation bundle also has some rules that calculates the change. That's all. Any questions?
Thank you very much. So now we have the Q&A session. So if anyone here or online.
Just to mention that we need to remind our instance that there is a link for the questionnaire. We posted the link on the chat. So please feel free to take the link and provide us feedback. We will also upload this presentation here on YouTube in case you want to revisit and be able to provide your feedback there as well. I don't see any questions on the chat at the moment, but if you have a question or a comment, please raise your hand or type your question on the chat.
Given the project, when you read it, that is not what you should do after that. There are something that the end user or get information from what needs to do to solve the objective of the remaining.
Two things. First of all, for example, for Ubuntu. Okay, we know that Ubuntu is version 21.4. So if you know the CPs and the products, maybe you can update the software in order to resolve these issues. So you have the complete list of the CPs, so you can check and modify, maybe update a specific asset. So, for example, I remember the year we had the log4j vulnerability that affected many Java products. Apache, if I remember the vendor, creates a new version that resolves this issue. So, first step, check if you can update the version of your product and, of course, update the CP. Then you have also the controls, which actually the mitigation measurements that already mentioned. Okay, obviously this is something conceptual, but you can define a control and say, okay, I can resolve this bug. Let's say you write you implement custom code to resolve the vulnerability, and you report this to the Cyrene platform. That's why. So give me a minute, Julio. Describe something. That's why when I create a new risk assessment report, I choose no controls. If you choose real, our calculation take into consideration also the control I presented there. But for a demo for 30 minutes, it's too difficult to define the data, etc. So I demonstrated more of the lightweight.
No, it was just exactly in this point, some questions from a participant, from Boria, asking why don't we include the mitigation actions? Yeah. Thank you.
Due to time constraints.
Another one. The surveillance of the network and something like that. The mechanism to check an officer to check if there is an attack, but also push mechanism give the word of take them another without having to check periodically something is wrong, and proceed in the solution.
No, you can continue querying the network tools.
Notification to the user.
Notification, exactly. Okay. We haven't implemented this feature yet, but it's in our plans yet.
Have a question from the chat box. From Portugal is writing right now, and that's why don't you include mitigation actions?
We already from that.
Okay, because we can, right, Cyrene platform and abroad you beyond the supply chain. That's what we ask.
Okay, the autocomplete functionality is based on the Cyrene methodology, but if we can configure the tool, the risk assessment subcomponent to execute risk assessment in a single organization or internal process, etc. But the users will lose some autocomplete functionality, or we have to redefine the autocomplete functionality based on the different attachments.
The scenario for the real world is that you find some CPs, know how they get the leadership, and then you try to resolve. So the first step is the aspect that have the CPs. You can run assessments that make the lives of that. So you are now being sure that the tasks are not attacked by each other. So you know that the tasks are not attacked, and it will solve the issues that so now we have to understand how the system is.
The main problem is when you implement something custom. For example, MongoDB is a product, the CPE, the updates, whatever, everything. But if I use custom Java code to implement something, there's no CPE, because it's something completely custom. That's why we need IDS or other components in order to identify risks in the custom code. And yes, as you mentioned, we have to add the notification. Yes, we are in our plans.
If we don't have more questions, I think we can close this event. Thank you very much, all of you, for attending here in person or online. And I hope you enjoy the demonstration. Thank you very much.
So thank you all for participating in this pilot event. I'd like to thank very much the representatives of Port of Valencia for hosting this successful event. And bear in mind that we have shared the questionnaire link, and please provide us an evaluation to give us feedback and based on your user experience. Thank you very much.